Hello everyone, welcome to the channel Understanding.Concepts.Of.Physics. So this is one of the doubts which has been asked by one of a physics enthusiast, a student of subject, and you can pause the video and go through the question. It's a numerical from gravitation, and I'll just highlight what things are given. So they have given a pendulum, and that pendulum has a mass of m, and it is hanging from a ship. It's along the equator, and the ship is aligned in east to west direction. When the ship is stationary with respect to water, the tension is T0. So right now nothing is happening, that ship is also at rest and the tension is T0. What we are supposed to find out, find the speed of the ship due to the rotation of the earth about its axis. So that's the first thing. And we are supposed to find out the difference between the tension and the earth's attraction, that is the gravitational pull. And the third aspect is, if suppose the ship starts with the velocity v, what is the tension in the string? And they have given angular velocity is omega, and the radius is capital R. So those things I have just represented in given. Mass is given, mass of the bob, radius of the earth, and omega is the angular velocity. Ship is in east to west direction, and T0 is the tension when the ship is stationary with respect to water. What we are supposed to find out is the velocity of the ship when it is at rest with respect to the water, and then we are supposed to find out what is the difference in the tension and the gravitational pull, and we are also supposed to find out the tension if the ship is moving with a velocity v. So just to give you an idea, this is our earth, and this is the north pole and this is the south pole, and this is the west and the east. So north, south, east, west, and the earth always rotates from west to east, and that is because we always see the sun rising from the east. So because the sun rises from the east, the earth is rotating from west to east. So that's the way it works. And the ship is along the equator, so this orange color is a ship, and which is along the direction of from east to west. So this is the direction of the ship. So this is something what you see from outside the earth. Now first and foremost, what they are asking is, what is the velocity of the ship when the earth is rotating? And that is pretty simple, because it's rotating with respect to the earth. Because the earth is also rotating, the velocity of any object on the earth is v is equal to r omega, and in place of r, the r stands for the radius of the earth, and omega is the angular velocity of the earth. So this is pretty simple. This is the radius of the earth, and this is r, and because the earth's particle is rotating with an angular velocity omega, and so the velocity is coming out to be r omega. So the first part is very simple, very clear, how much is the velocity. Now second part, in order to understand the second part, I have drawn this diagram with a different perspective. Like if you see that if you see this diagram, this is the earth from side view, like you are seeing from outside the earth. Now suppose if you are watching it from here, let's say you are watching from the south pole, you are only seeing the Antarctica part of the earth, then it would look something like this. So this is that south pole, and north pole you are not be able to see in this, because the north pole is on the other side of the screen, and the west is on the left and the east is on the right, and the earth is revolving from west to east. So this is the way the earth is rotating, and this is shown as the equator. So we are basically watching the earth from the bottom, and this is the ship which is standing on the equator, and which is facing the facing from east to west. So the ship is going to go on this side. Okay, so let's say the ship is about to go on this side, and this is the pendulum which is hanging. So let's see how it works then. So if you see this pendulum, there is this gravitational force acting downwards. I'll just this is the gravitational force acting downwards, and the tension in the string acting is upwards. So in this case, if you see, because the ship is in a circular motion, something like this, then the centripetal force is acting towards the center, and this centripetal force m omega square r is brought by who? Brought by mg, that is the gravitational force. So mg minus, and tension is upward, so tension is upward, so that is T0. So mg is downward, tension T0 is upward, and the centripetal force is downwards. So centripetal force is brought by gravitational, and T0 is exactly opposite to that. So this is what they were asking: what is the difference between the gravitational pull and the tension? In the find, I have written T0 minus mg, but yes, it's mg minus T0 is also the difference, and that is coming out to be m omega square r. That's the B part. Now the third is, okay, suppose if this ship actually moves to the uh, left, I mean toward the west. It is because it is pointing from east to west direction, it is pointing this way, so it is going to move in this direction. So then what is the tension when it is moving? So I've just copied the diagram over here. Equator is this, south pole is this, west is this, east is this, and the north pole is on the other side of the screen. Now let's say okay, we have this ship which is moving in this direction. Now the earth is moving in the opposite direction. The earth is moving from west to east, and the ship is going from east to west, so the velocity has to be subtracted. So in my equation, how are we going to create this? Again, the same concept here. The centripetal force, that is m omega dash square r. Now why is this omega dash? Omega dash because there is some net velocity. It's not only the velocity of the earth, it's also about the velocity of the ship. So that this is omega dash, which is the net velocity, which I can say that velocity of the ship minus velocity of the earth. Okay, and this is the centripetal force, which is brought by gravitational force minus the tension. So the tension is T upwards. Now the tension T is equal to, I've just moved this T on the other side, so negative becomes positive, and this terms goes on the other side, so it will become negative. Now what I've done is mg is replaced by these two terms which I have already found out. So mg would be equal to m omega square r plus T0. So this term goes on that side and it becomes plus T0. So wherever there is an mg, I have written as T0 plus m omega square r from the previous B part. This is from B. Okay, from B. Now m as it is, and omega dash, that is the net velocity, is nothing but ship angular velocity minus the earth's angular velocity. So earth angular velocity is given as omega, so I am not changing that to omega e. I am just writing as omega. Omega is the angular velocity of earth, omega s is the angular velocity of the ship, r as it is. Then keep this term as it is, just copied these two terms, you square it, so a square minus 2ab plus b square, that would be our expansion. So omega s square minus 2 omega s into omega plus omega square. These two terms as it is, keep it as it is, open this bracket. So minus will change all the signs, so this will become minus, this will become minus into minus will become plus, and minus into plus will become minus, m multiplied and r multiplied, so mr and mr to the above equation. So it's just a basic math. Then T0 as it is, and if you see, minus m omega square and plus m omega square gets cancelled, so I've just cancelled these two terms, and what remains is these things. But as you know, omega s, that is the angular velocity of the ship, so v is equal to r omega, so omega would be equal to v upon r. Now this is for ship, so I'm just writing that as omega s will be replaced as v by r, and because it's a square, so v square by r square, r as it is, plus 2m as it is, omega s, wherever there is omega s, we can write as v by r, omega r as it is, so omega r as it is, m as it is, 2 as it is, r as it is, m as it is, these things are cancelled, and wherever there is an omega s, we have written omega v by r. Lastly, if you see, I can cancel out 1 r from here and 1 r from here, so what remains is 2 mv omega, and here what remains is mv square by r. Now if you see, the velocity of the ship and the mass of the ship is too low in comparison to the radius of the earth. So the radius of the earth is 6,400 km, which is pretty large compared to these two things. So this term is negligibly small. So because mv square by r is negligible compared to the other terms, I mean compared to this term and this term, we can say that it will be ignored. So I have ignored this term of the center, and what remains is T is equal to, that is the net tension while it is moving, is equal to tension while it is not moving, plus 2 mv omega. This would be the answer for the C part. So thank you so much for being with me all the time. Thank you so much, and subscribe the channel in case you have not done so, right? And in case if you have any doubts and difficulties, you can just comment me on the section. More doubts, I have got some more doubts, and I will be clearing that as soon as possible. Thank you so much. Have a nice day. Bye.